objective was to determine the frequency of the major scale notes in order to know its place on the string. So the theoretical analysis is the frequency that can be calculated with lambda and the velocity. Since lambda is n divided with 2L, then the frequency can be n divided 2L times the velocity. And our string was measured by 0.69 meters. We investigated the open A frequency of our guitar, and it was 110 Hertz, and so the velocity was 151.8 meters times second. That velocity we can determine our longitude.
And devices we used was a wood plank, a guitar string, a hammer, nails, hook nail, taquetes, flexometer, and frequency analyzer.
Experimental development. To begin with, the taquetes were nailed to the wood plank and the bottom and the top part of the prism. The hook nail was perforated with a drill and was placed behind the top taquete. After that, the bottom part of the string was strung around the hook and the string was tuned in a regular guitar tune to A. The using of the flexometer, the lengths calculated were marked in the wood stimulating the frets of a guitar. Finally, the frequency analyzer was used in order to check that the pitch was correct and match the theoretical result.
We used the formulas stated in the theoretical analysis in order to input them in an Excel and get the longitude of each note for 3 octaves.
After we got the guitar together, we used a flexometer to mark the spots where the frequency of the notes will be according to the theoretical results of longitude calculated in Excel. After that, we used a frequency analyzer and the guitar tuner to prove that the frequency of the guitar was emitting the same frequency as the theoretical one.
So just as Elias was explaining, after getting the longitude of where the frets need to be in the guitar, we use the Vernier Logger Pro app in order to help us with the spectrometer to know if the frequency that the instrument is producing is pitch correct. We used the C note, the D note, the E note, the F note, and the G note, and the next octave of the A note in order to verify that the results were correct. After getting those frequencies, we compared them with the theoretical ones we used in Excel, and after comparing them, we saw that the pitch was correct. There was very little variation between those pitches, and that variation is due to the fact that we lack the metal frets that regular guitars or instruments have. So the fret helps us to cut the guitar to the proper length to produce the proper pitch. So that is a little variation, and that made us have a little bit different results, but they were less than 1% in the percentage error. The percentage error was 0.46%. In conclusion, we can say that the frequencies were the ones that had to be in the pitch, and that the longitude was very well calculated and the pitches were accurate too. Thank you for everything.